Mike, leaders always say our data is too noisy to adopt AI, but you say machine learning can help solve that noise.
Mike Foley is a seasoned analytics strategist who has been building high-performing data science teams since before the term was officially coined. With over 20 years of go-to-market experience in strategic planning, sales, and marketing, he specializes in bridging the gap between complex technical models and actionable business results. Mike utilizes a hands-on approach to data strategy and machine learning to help leaders navigate common pitfalls, secure organizational buy-in, and transform noisy data into competitive advantage. You can explore his latest insights and thought leadership at his blog, mikesdatamarketing.com. Let's dive into the conversation with the guest himself, Mike Foley.
That is a common complaint. It has been forever, that the data is imperfect, for as far back as statistical modeling, in the 70s, 80s, and so forth. But now with huge volumes of data, you see much more noise, you have sparse or missing data, you see incorrect data. So machine learning has become practical for a lot of reasons for industry to apply to large data sets. And machine learning is a learning system, exactly what it says. The machine learns because it can go over and over and over again, large volumes of data that cannot be handled by statistics, and look for the patterns in the data and come up with a prediction, for example, or a classification or an answer.
What waiting for right data can cost leaders, companies in the short and the long runs?
Yeah, when big data came out, I recall McKinsey did a report on that showing the ROI for companies that adopted big data, machine learning, artificial intelligence versus their competitors. And really, there was a clear correlation between increased ROI, increased sales, and adoption of big data, artificial intelligence, and so forth. So that's all been documented. And really, you have to look at your competitive set and say, am I an analytic competitor, or am I being out competed by other companies that are using all these techniques now that are pretty well established in most industries?
Companies collect a lot of data. They save data, they keep data. And there is also a saying data is gold. Where the gold is, if there is no insight, there is no actionable output from that data. How to turn that gold into insights?
A while back, the economists characterized data in the introduction of big data, probably around 2012 or something, as the new oil, as a resource. So you have to look at data as a resource. And data became larger and larger because of two things, really. The Internet of Things, casting off tons of exhaust from your refrigerator, your car, everything else, and social media, huge exhaust from that as well. So now you have all this data. The price of storage has come way down. So the data, there's no ROI on transforming, formatting all that data. You just store it because the cost of storage is so low. So all that exhaust is just stored somewhere. Now you have all this fuel. What can you do with that? It can't be handled by normal statistics. Now machine learning becomes practical because of uh, high compute, like NVIDIA with gaming GPUs that were introduced that could handle a machine learning algorithm that learns over and over, trains and tests for days to come up with the optimal solution, looking at the patterns and all that data. So that becomes practical now. And that means that all that data that's been exhausted from uh, social media, Internet of Things, your internal infrastructure can be used to develop models, decision support, uh, agents now, AI agents that can solve different problems for customers and so forth.
There are a lot of relying on agentic AI, and it's a boom. I mean, there is no other thing going on right now. Everyone is focusing on agentic. Have you tried it? How
Yes.
how can it help? I mean, to what extent? There is also conversation about responsible AI and guardrails on AI decisions,
Yeah.
human factor in the AI emotional aspect. How all that can be handled using agentic AI to make big decisions on behalf of businesses.
Well, I built some agents myself, and I put my abilities up against them. I did a test, like a competition between what I could do with machine learning and interpreting it and coming up with answers versus an AI agent. Well, first of all, agentic AI relies on Gen AI, which is another level of machine learning. When we're talking about machine learning, that means a lot of things. But as data became more available, we got into deep learning, which could deal with many, many layers of complex representations of data, like photos and image recognition, all that. And then Gen AI, which are these large language models like Gemini, ChatGPT, and so forth, that actually create new data. So now you've got a machine that's not giving you back, this is a customer, but you have a machine making up answers, and you have all the implications of that. So an AI agent can be hooked up to one of those machines. And so not only does it have all the power of like a Gemini behind it, but also the speed. For example, for me as a statistician looking at the data, there's no way I can come up with the solutions as
Yeah.
quickly as an AI agent. For example, in my competition, I gave it access to one of my machine learning models, and I said, "Here, if you look at this customer data, come up with a program to market to those customers." 45,000 different customers, and it came up with an individual program for each of those customers, like that. It would take me weeks to come up with that, to analyze all the data for each of those customers. You can imagine huge spreadsheet, columns and columns, and come up with a program to communicate to each of those customers individually. There's no way I could compete with that. Now, there's things I can do that maybe I know things that the machine doesn't have access to, or I can think a big picture where we want to go. So human being involved, I think, is still important. But for just the ability to look at a large amount of information and come up with a solution, it's super handy for that. I think you're going to see it in dashboards, replacing dashboards or supplementing it, all kinds of purposes in a company where you just want quick response with all the data we're talking about. A human just can't make sense out of this huge big data that most of these companies have.
Yeah, and reporting is also turning into like real-time notifications.
Oh, totally.
Yeah.
You ask a question, you don't have to go through these huge Tableau or Power BI dashboards. I hook it up to the same data and you just say, well, give me a customer that's likely to buy this product. Here's a description of the product. We haven't even introduced it yet. Give me a list of those customers, and like that, you got it. You don't have to figure it out yourself. It will give you the recommendation.
Yeah. In my world of digital, like I come from marketing, and there is a challenge to personalize digital experience at scale. Okay, talking about tens of thousands,
Yes.
hundreds of thousands of customers at the
Right.
same time, and marketing and personalization is all about like right content to the right people at the right time. In order to do that at scale, especially in the B2B segment, the challenges are even more because it's not one person to attract. In that criteria, in that situation, like how can agentic AI help boost that customer data to identify the intent signals, where are they busy, and how they have been interacting with us, like, and what to recommend them at the next level. What is your take about this situation and how AI and high quality data, even not high quality, as we started with noise and like machine learning can help, like how all that situation can be handled quickly?
That's a good scenario. And what you described is something you really want to develop the talent for prompt engineering, which is asking the questions you're asking now of the agent. Now, the agent itself is connected in this hypothetical scenario to all of your data and all of your models. So all the models that were built, to calculate propensity to buy, to predict customer lifetime value, to predict if they'll churn, to predict what segment they're in. Are they, high-end shoppers, what have you. All those models it has connection to. It has connection to all your data, but also to other agents that might be coming off customer support, service records, the Internet of Things from your install base. It has access to all those things. Now, the key for the marketer is to be able to ask the right questions. And in fact, as a prompt engineer, you can say, give me the right questions I should be asking you. So you can even turn it back to the agent and say, can you, and remember, it's also connected to a large language model with all the information that has, from Boston Consulting Group, growth share matrix, best practices, all of that. And the speed with which it can compute all of that information to come up with what you're asking for, if you're asking the right questions, and it can be a sequence of questions. Okay, look at all that. Give me the customers out of my 500,000 customers, give me the 20,000 best. Now give me the 5,000 ones that are most likely to purchase my product. Now give me an individual communication for each one of those customers based on everything from their web behavior to the models to all that. Give me the best communication. Now give me sentences that give me products that I should be putting up in personalization individually for each one of those. And you just give me the file. You could have the file of top 5,000 customers, a recommendation from a recommender that these are the products we should be promoting. This is how I should deal with this customer, because remember, some customers may have service problems. Some customers may be extremely happy. Some customers may be high potential, but they're dealing with competitors. They're in different industries. Those customers are all different. So one message is not going to be as effective as different messages that are tailored to the characteristics of each customer based on all the information and all the modeling you have for them.
When you say machine learning, because what I'm coming from right now is like, okay, all that looks good, sounds good. But to start with, like leaders say that data is noisy to adapt AI. Okay. And you say machine learning can help fix that data. If the fear like data is not right and LLM can suggest something incorrect, can make us make bad decisions, how to rely on data? Most leaders also think um, like don't even know where they are, right? Where they are in the data maturity curve. Okay. How to enable them for data awareness, okay, and how to fix that noise in data that you say machine learning can fix that or increase the confidence of data accuracy to be ready for AI. Because all that, the scenarios that you're suggesting are great, but the baseline is data. And AI is all about garbage in, garbage out. If data is not right, your prompt is not right, this is gonna spit garbage out. So in that situation, coming back to the core question here, like how to fix data if we think data is not good.
Before big data, when you had small data, a statistician would look at the data and they had an expression, let the data speak. And you might have 10 characteristics or 20 characteristics of a customer. And you'd go through and statistical models are very brittle or very static. You'd have to look through and look for outliers, missing data. You could correct for missing data by inferring based on other characteristics and fill in the blanks on the missing data. You'd have to look to ensure all kinds of statistical things like independence and normality and all kinds of characteristics of the data. So most of the work was done on data preparation to make it usable for a model that could really deal with maybe 5 or 6 characteristics, for example. And if you put in information that was redundant, you're just increasing the error with no increase in the model effectiveness. Now, with big data, say you have 200 columns, if you picture a table with 200 columns going across, it's not looking and it's not correcting for all of those characteristics. What it's doing is looking for patterns in the data that will allow it to make the prediction you're asking it for. And so one row might have certain characteristics missing. The next row
Yeah.
might have those rows filled in. So now it can learn from the data itself, looking at all sorts of different examples in each row. It trains, tests itself, just like a kid in school, training, testing over and over. And each time it tests, it looks at its score and where the errors are. And it could do that 1,000 times and each time it'll go back and reweight and learn from the errors of the previous what's called a weak learner. So you could do that 1,000 times because you have the compute to make these what they're called little learners or weak learners over and over and over again. So each time the ability to model and predict is improving. And finally, it comes up with the best possible solution, testing and training. And you can see the error rate over time changing. And you see that at the end, you have the best possible prediction. But you also want to be able to have the ability to generalize into the future because things will change in the future. So you want to leave some room for error, not just memorize the data, but also leave some room for generalization, just like a human mind. Through experience, the human learns to recognize an octopus, and an octopus could have different characteristics, slightly different colors. Some information may be missing, but you could look at many, many pictures of an octopus and say this is an octopus, even though it's slightly different each time.
Yeah.
That's
Yeah.
what's happening with machine learning, if that makes sense.
No, that's true. Yeah, that's most important stage, I think, before we're gonna try something big. We do a lot of pilots, but we never can scale just because we're always running in loops of getting better.
Machine learning is just like a person in that way. And the language that you use to discuss machine learning, you learn the machine, or the model has weak learners that over and over again tests and trains, just like a kid in school. It's learning each time. And because of all the technology that we have now, these things that were theoretically created many years ago are now practical in industry because of all the data. When you have so much information, just like a human mind, and you can fill in the missing blanks and you can still come up with a good solution.
Most companies stuck into the status check also, like status check, or we can say like not aware of what the data is. I mean, we all talk like we have a lot of data, but what our data maturity stage is, where we stand in terms of our data quality. Is there a framework to measure it? Is there a way, like, okay, how to compare against the benchmark or the best practice? Where do we stand?
You could make a case that we don't have enough data. So when you're training in deep learning, more data is better. So now we have, and I've done this myself, building models where we have to create what's called synthetic data. Pictures, say you're doing image recognition and you don't have enough, you feel like you're not getting enough accuracy. You'll create images that allow you to train images that look like an octopus and images that don't. You'll create new data, or data that looks like a customer and data that doesn't. Synthetic data to give more practice, more iteration for the machine to learn on. You can also do all kinds of techniques to infer from missing data, to fill in the blanks if you need to, but that can be risky. Or you can normalize the data. It's called normalization, correct data. You can transform data in a lot of ways. And that goes back to statistics, where you remove outliers, you change data in ways that make it more valuable for a prediction. The most important thing is that your prediction, when you compare it to predicting things that happened in the past, the error is very low. You want your prediction to be really high, and you can transform data in many ways that looks on the surface to be bad to make it usable for predicting the future. And you can test that because it's called, like, I think layperson's term is back testing, where you'll go back to historical data that you have, this is a customer and this isn't a customer. You'll hold that out and you'll say, go back and do the prediction. And then you'll compare it to actuals and you can see how accurate it is in predicting historical data.
How much data is enough? I mean, you said we can build a case, we don't have enough data. Then what is that benchmark?
Depends on the problem. Like, you see these large language models. Now, the difference there is they're creating new data. And sometimes you'll ask it a question and maybe it doesn't have enough data to really accurately come up with the answer. So it creates a new answer. It just makes up an answer. And that's where you get into hallucinations and stuff. It's trying to answer a problem, but it doesn't have enough data to answer it. So really, you have to look at what you're trying to do with the data and saying, when I'm doing what I want to do, whether it's predicting whether a customer will buy, or predicting cancer, or predicting the weather, when I go in and try and uh, do the task that is given to me, do I have enough data to do that? When I test and train and I go back and I look at the test scores, did that student study enough that it got an A on the test, or a B? If it got a C, well, maybe I need more data to train it. Maybe I needed to go back to school. So that's where you make that decision. The data itself, that is why you just store data. You don't, in the old days with relational databases, IT teams would go in and they'd format, massage all the data, make it the data was curated for specific purposes. But in the era of big data, you would go bankrupt going in and doing normalization and doing all the IT tasks to make every table in a large data lake, which could be 10,000. I've seen 10,000 data lakes with 10,000 tables. You couldn't go in and fix all that data to make it usable. You fix it as needed for the purpose you have in mind. So you really have to work from the problem to back to the data.
Yeah, as we are going deeper into this conversation, yeah, it makes more sense to work as one brand. Like, I mean, if sales team is running their own machine learning programs, generating their own data, and marketing is working on a different set of data, it's gonna create mess for outside for customer experience, right? So that merger is important in the back end to train their data and machines to make sure that like the the output is accurate and relevant, and like it works for both teams. Also, it generates more data and they both can train their machines at a higher
Yeah. Yeah, it makes sense. It's just not practical to have silos. It's just not practical. There's no reason to have it. And really, you're at a disadvantage if you are, because if your competitor is building models that go cut across all go-to-market strategy, they're building a propensity to buy model. I'm making that up. It should be used, the output for a unified go-to-market has got to be used by sales, marketing, customer service,
Mhm.
strategy.
Yeah.
When you're saying this customer is the one I want to prioritize, or this prospect, you want I mean, just from a practical implementation standpoint, your digital team, your field marketing team, your sales force, your service support when they call in, your your annual strategy, all to be singing the same tune about that account or that customer, right? You wouldn't want them all to come up with different conclusions. If you think about it, not only is it a waste of data, a waste of storage, a waste of data scientists' time to add multiple models, but you just have your approach to the market is going to be schizophrenic. Okay, this one is high potential. This division says they're not high potential. This one's anyway. I mean, you could see that all the way to the unified go to market, and a unified approach to the customer, whether you're in B2C or B2B, data all the way through has got to be one unified approach. Does that make sense?
Yeah, exactly. And from your experience, what you have seen, like whose responsibility is that to consolidate all the data, combine all teams in terms of training the programs?
It really is a collaboration. It's a team effort. You know, you IT can build the containers, but they cannot prioritize what should be in them because, again, we're talking about a unified go-to-market, unified approach to the customer, treating the customer the same way across all touch points, whether it's telemarketing, customer support, email blasts, field marketing events, digital Salesforce interactions. All of that information has got to be captured to have the optimal go-to-market, for example. And if we go to uh, a reference book that I read some time ago in school by Davenport and Harris, they were like the gurus predictive analytics and competitive. They wrote a book called Competing on Analytics, which was a textbook in I think it was mid maybe 2010 or something. But they broke companies up into 5 stages. Stage 1 was incompetent. Stage 5 was the best, and that was the pervasive use of analytics across the organization. So you didn't have, say, a marketing group that was really stellar on using machine learning and so forth, and statistical analysis, and a sales group that was left behind. Everyone across the board had shared the same capability, same models, same analysis, and that, of course, means the same data. Because if you're using different models, even with the same technique, you're going to have different results.
This is wonderful. Yeah, I'll mention this book also in the description. Now, this is great to learn from.
Yeah, it's a fabulous book. I was assigned it in a class when I was at Northwestern. Highly regarded. Those guys are like they're the gurus, and they still publish on analytics.
Thanks, Mike. It's a great conversation. A lot learned from you today. Thank you.
Well, thank you. It's a pleasure talking to you.
And that's a wrap on this episode. We hope you are walking away with at least one battle-tested strategy you can apply to your own digital journey today. This show is built for leaders like you who are tired of the fluff and ready for real solutions. If you found value in this discussion today, please subscribe to the channel and leave us a review. It helps us bring more world-class leaders to the table. Also, feel free to share this episode with a colleague who is navigating these same digital trenches. Thanks for watching, and we'll see you in the next one.